Hello everyone and welcome on day 14 of Admin of Cyber. Today's task is focusing on machine learning. So let's start with the questions. What is the other term given for artificial intelligence or the subset of AI meant to teach computers how humans think or nature works? So for this question, the answer is machine learning. And yeah, as you already know probably, machine learning is a branch of artificial intelligence. It's a subset of AI. So, and this is also the topic that we're going to talk about today. What machine learning structure aims to mimic the process of natural selection and evolution? If we go up here, you will be able to see genetic algorithm. So the genetic algorithm is aiming to mimic the process of natural selection and evolution. So if you copy this and we go down, lots of information for today's task. What is the name of the learning style that makes use of labeled data to train an ML structure? So if we go up, we're gonna see a chapter for the learning styles. Okay, so the learning styles. And as you can read on the supervised learning, you'll be able to see in this learning style, we guide the neural network to the answers we want it to provide. We ask the neural network to give us an answer and then provide it with feedback on how close it was to the correct answer. In this way, we're supervising the neural network as it learns. However, to use this learning style, we need a data set where we know the correct answers. This is called a labeled data set. So this is going to be the answer for this question, supervised learning. Let's go down. And as you can see, this is the correct answer for this question. What is the name of the layer between the input and output layers of neural network? So if we go a bit up, there is a chapter for the network, the layers. And as you can see, we have three layers in neural networks. The one is the input layer, the other one is the output layer, and the other one is the third one, and the last one is hidden layer. And this is the layer of nodes between the neural network's input and output layers. So this is the layer we are looking for. Let me copy this. Paste. Okay, I also put the colon, but it doesn't matter. So what is the name of the process used to provide feedback to the neural network on how close its prediction was? If we go a bit up, you will be able to see two processes. Let me show you. So we have feed forward loop and back propagation. So when we are training our network, the feed forward loop is only half of the process. Once we receive the answers from our network, we need to tell it how close it was the correct answer. This is the back propagation step. So back propagation is the step that we do the feedback process. Let me go down, paste it, and this is the correct answer for the fifth question. And for the last question, we have to do a task. We have to do the last chapter. And the question is, what is the value of the flag you received after achieving more than 90% accuracy on your submitted predictions? If we go up, first of all, you need to start the machine. You will need to go here on the top of the task, start machine. And after you do that, you have to open the split screen. You will be able to see this screen over here. It's either gonna be on the same tab on the side, or you can maximize it and it's going to be full size in another tab. So if we go a bit down, it says putting all together. So we have the detector py, the dataset train.csv, the dataset test.csv, and let's read a bit about those files. So detector.py is the script where we build our neural network. The dataset train.csv is your training dataset, and the dataset test is your testing dataset. So what we're going to need to do now is fill the empty spaces in detector.py. So there is already some code inside the detector.py, but we need to put some more. And here we're going to see some chapters that there is also some code that we need to copy and paste in the detector.py file. So creating datasets. First, we need to create the datasets. In our case, we will use an 80-20 split. We will combine our validation and testing datasets, as we will use the completely new data for our testing dataset. To do this, we have to add the following line in our code after the insert dataset split code here. So we copy this line, we go on our screen, on our VM. So you need to open neural network, and then detector. I'm going to open it with Vim, and then I'm going to close this directory. Okay, so here we have the detector py file, and we're going to need to put this line of code under the insert dataset split code. So insert dataset split code here. If I go here, Control V, yeah, it doesn't work for some reason. So I managed to do it. I just had to open it on a split screen, and I will use the clipboard here. So now you can see that I pasted the first line, this first line here, in the correct place. Now let's try to do the second part. It says insert normalization code here. So for the normalization code, we have normalizing the data. Next, we need to normalize our data. We can do this by adding the following line in our code after the insert normalization code here. So now we will need to copy this. I'm going to go to clipboard, paste here, and then paste also here. Control Shift V for the VM. And now that we did also this part, let's go down. As you can see, we have the classifier code. Let's read. So training the neural network. Finally, we can train our neural network. First, we will create our classifier with the following code. After the insert classifier code here, this is the code we need to paste. I'm going to use the clipboard again. Okay. Perfect. Now we need to put the training code. So training code is going to be this little line of code. Oops. I made a mistake. Okay. Now paste. Perfect. Then we have the classifier validation prediction code here. We will need this. So validate our neural network. This next step is to validate our neural network. To do this, we can ask the network to predict the values based on the validation dataset with the following code after the insert classifier prediction code. So we go here, paste, oops, again, I'm gonna need to use this code. Perfect. And after that, as you will see, when you execute the scripts, predictions are significantly faster than training the network. This is why neural networks can actually be used in real-life applications, as the prediction rate is incredibly fast. Once the network has been trained, we can determine the accuracy of our classifier by comparing the two arrays with the following code. So now let's try to run the code. Now that we ran the program, you can see that we get a network accuracy of 91.795%. Now what we need to do, as you can read here, these predictions will be saved to a file. Upload your predictions here on this website. So to upload the predictions on the website, we need to open the browser on the virtual machine that we get from TryHackMe. And here, browse, we have to go neural network, the file, predictions.txt, and then upload. And as you can see, file uploaded successfully, feedback file was processed successfully, accuracy 91.44%. And this is the flag that we get for completing the task. If I go down, paste it, and it is correct. So that was it for today. I hope you guys enjoyed the video. I hope you had fun, and see you on day 15 of Admin of Cyber.